We have limited satellite coverage in this area overall, because the satellites tend to go around the Earth rather than go for the poles. We also have limited radar coverage in this area. So the Polar Gap project was designed to fill in one of the last remaining holes in Antarctica.
And this was a European Space Agency initiative, right?
Yeah, that's right. So it's funded by the European Space Agency and the British Antarctic Survey. So we've been working closely together to collect this data, and then I've been analysing it at Northumbria University.
Okay, and ESA was most interested in the gravity measurements, but you were interested in the radar data.
That's right, yeah. So I wanted to know what was happening beneath the ice sheet. So what we did was we used radar to look at the subglacial topography, and that's when we found 3 deep subsiding ice towards the ocean. So they're draining the West Antarctic ice sheet. And they're actually separating the flow of East Antarctica from West Antarctica. So we've got mountainous subglacial topography that's preventing ice in East Antarctica flowing out through West Antarctica.
And explain how you get that information. You do it with an instrumented aeroplane.
Of course, that's right. So we put the radar on the plane. It's called airborne radio echo sounding. That's the technique. And we also have lots of other instruments that allow us to know where the plane is. So we've got GPS measurements, and then we've got LiDAR measurements that allow us the surface. So what we get is effectively, it's like an X-ray of the ice sheet, so that we can look at the layers in the ice, and we can also look at what's beneath the ice, so the subglacial topography.
So you found these enormous troughs. Give us a sense of scale. Just how big are they?
Yeah, so we've got one of them that's 350 kilometres long, and the others are closer to about 300 kilometres long. And that's the equivalent distance of kind of London to Manchester. And they're about 35 kilometres wide. So I think that's about 1.5 times the length of New York's Manhattan Island. So there's really big channels, and it's quite incredible that we didn't know they were there before. And that's just because of the satellite gap at the South Pole and the radar gap at the South Pole.
And these troughs, they cut through big mountains. The valleys have really big sides, yes?
Yeah, so they've got really high sides, which allow them to contain a lot of ice. So when we noticed them, we realised that the ice is kind of being controlled. The direction of ice flow is being controlled by the direction of these troughs. She was to start to thin in the future. Maybe if the climate warms, the ice will start to really flow through these troughs and flow faster towards the ocean.
Because if you look at a map of ice elevation in this region, these troughs underlie the so-called ice divide, which is kind of like a watershed. The ice moves away from this region to the east on one side and to the west on the other, yeah?
Yeah, that's right. They cut right through the ice divide, so there's really long troughs, and there's mountainous topography on either side, so you've got really big mountain ranges on either side, so they're really controlling the flow of ice. Ice has to flow through these troughs.
So the expectation then is that the West Antarctic ice sheet will thin in a warming world. What happens then? How do these canyons come into play?
So we expect that these troughs will allow ice to flow from the centre of the continent towards the coast. So they'll facilitate faster flow than there is at present, which will help to, I suppose, thin the centre of the West Antarctic ice sheet, and that will in turn raise global sea levels. But this work really feeds into ice sheet models, so predictive models that we'll use to see the influence these troughs will have. But we couldn't use these models before because we didn't know what the topography was like before.